I'm here with Dr. Vinka Craver of the University of Rhode Island, a professor in the Department of Civil and Environmental Engineering. We will be discussing her research in the areas of water and wastewater treatment supported by the Rhode Island Water Resources Center. Her latest project is entitled The Use of Manometric Techniques to Evaluate the Disinfection Properties of Nanomaterials for the Treatment of Different Sources of Drinking Water. Good afternoon, Dr. Craver.
Good afternoon, Archie.
Can you briefly explain what your most current research is for us?
Yeah, sure. I'm interested to study about how different nanomaterials can be used for water treatment, specifically for disinfection purposes, because there are several new nanomaterials that have disinfectant properties that are very extensively used in other fields, such as medical sciences and some material sciences as well.
Okay. And what are those nanoparticles that you're...
Well, I'm mostly interested. I've been extensively studying the silver nanoparticles, which is one of the most common nanoparticles currently in the market. About 80% of the nano products contain some type of silver nanoparticles. And there are other particles, for example, copper, zinc oxides. There's a very wide number of nanoparticles in the market currently.
Okay, and as far as like silver or copper nanoparticles go, what is it that makes them a nanoparticle?
Well, there's a technical definition of nanoparticle. Is basically a nanoparticle of a nanomaterial is any particle that it has a size or one dimension at least 100 below 100 nanometers.
Okay,
actually.
but so that I can relate to it, it's still silver or copper?
Still, it's like a tiny little particle of silver. Really.
Okay. And what properties about these make them good disinfection agents?
Well, they have been tested with different pathogenic organisms that they can deactivate them or kill them very effectively. So mostly, again, they have been used for medical purposes. For example, for applications and wounds, they need to be wet all the time, and that usually could cause some infection. But if you coat it with the silver nanoparticles, you prevent the growth of this bacteria and prevent infections then.
So you're looking to disinfect water?
Yeah, I'm looking to disinfect water.
Okay, and I know that your focus is for small-scale water disinfection. Can you give us an example of what small scale means?
I'm very interested to develop and to improve, create or develop systems that are going to be for at the household level. I'm more interested on that. Like that means like a house will have this system maybe in their, underneath their sink, or then maybe they can have a little jar with this type of system. Yes, for family type of use.
All right, and I've read before within your work that it's you've been targeting developing and undeveloped countries.
Yeah, we have, there is a very widespread application of ceramic water filters that basically looks like a pot-like ceramic system that you place on top of a bucket, and then the dirty water goes into this ceramic pot, and then through the pores of the ceramic that is coated with these nanoparticles, the bacteria is retained and killed, and then the clean water is stored in the plastic bucket.
So how is this technology relevant to Rhode Island's small water systems?
Well, there are several people in Rhode Island that have wells as a main source for drinking water. And even though we have very good quality in this well, I think that the latest flood give us an idea that this system could be in some type of threat because of unexpected event. It not only necessarily can be a flood, but imagine like a chemical spill or something like that.
So theoretically, if your well were to be contaminated, you can use this system to disinfect, and then you can, it's small scale, so you would have it at your home, and you'd be able to drink the water that day.
Yeah, for example, you can still take the water from your well, and then you can pass the water through one of the system, and you can have safe water in terms of bacteria. That's what my main target.
And also in your research, you mentioned disinfection byproducts. What are those?
Well, one of the reasons that I'm interested in the silver nanoparticle is because until today, really, there are not an evidence that these nanomaterials can produce disinfectant byproducts. And disinfectant byproducts are going to be undesirable compounds that they are produced when the chlorine interact with organic matter, usually commonly dissolved in natural waters.
And chlorine is what we now use?
Yeah, chlorine is very
large scale
it's large
disinfection?
scale. Exactly. Okay. In big water treatment plant, chlorine or chlorine compound or chlorinated compounds are used for disinfectant purposes, which is very effective. It's very useful. It's cheap. They have several advantages, but they are in different settings that I think products, other type of disinfectant could be used.
Okay, so chlorine does create disinfection byproducts.
Disinfectant byproducts, yeah.
And nanomaterials do not?
Until there's no evidence that they don't produce it.
As of yet, we don't know if nanoparticles
exactly.
do.
You know, all the time there are new discoveries. So.
Okay. And what about the taste of chlorine? Would there be any associated tastes with disinfection through nanoparticles? So
far with the ceramic filters, people haven't really complained about taste. So we think that they are not a residual taste from these nanoparticles.
And what are some common byproducts? I mean, what are the harmful health effects of byproducts?
Well, some disinfectant byproducts, there's a very wide range that go from some, I don't know if aldehydes or other compounds that I'm not going to try to say.
Okay, so a little bit in depth, but...
In depth, there is not really, and there is some evidence that this disinfectant byproducts can be precursors to cancer. But this study has been mostly done in animals. There are not really direct evidence that this product can cause cancer in humans, but there are some concerns that this product could.
All right, so better to avoid that than have to deal with
well, there are different strategies to avoid the production of the disinfection byproducts. You not necessarily have to avoid to use chlorine. I mean, you can try to remove the organic matter also.
Okay.
But yeah, right now there is a tendency and try to reduce the amount of disinfectant byproducts that are produced during disinfection processes.
Okay. And how is your current investigation related to other topics that you've studied so far? I know that ceramic filters was possibly last year's funded project by the Water Resources Center, and the year before was silver nanoparticles, and this year it's specifically, could you fill us in on that, what it specifically is this year?
Well, from the results that we obtained for the previous two studies, we figured out that it will be interesting to study two things and try to investigate other nanoparticles that they can have similar or different disinfectant properties. I mean, different in the sense that they could be more effective with other pathogenic organisms. And also how different water qualities are going to affect the performance of these nanoparticles.
Okay, so locally in Rhode Island, we would have fairly good quality water?
Yeah, we usually have quality water, but in terms of, it's the water chemistry of the compounds that are going to be, I mean, drinking water is not only water. There are always going to be some salt or something that's going to be dissolved in the water. And that amount, in different amounts, and all is going to depend what is the source. For example, surface water have a different water chemistry than groundwater, or water that they are close to seawater is going to have different compounds dissolve, and that compounds could potentially affect how these nanoparticles are going to perform, how well they are going to disinfect the water or not. And that's what we're trying to investigate.
Providence's water treatment facility uses surface water, and local water would be gained from groundwater?
Groundwater, yeah. So we will expect that the groundwater have more compounds that are going to be dissolved, which is
that needs to be removed?
Perfect. No, not necessarily. I mean, there are still if you have a well, that means that water is suitable for drinking, and it's fine. It's all natural salts that they are going to be dissolved. But you expect that groundwater is going to have a higher concentration of these salts than surface water. I mean, surface water might have more turbidity than groundwater, but they are different, but that doesn't mean that one is better than the other.
Okay.
But they are going to have different chemistry. That's what sometimes you when you go from one place to another, you feel a little bit of taste in the water, but it's not
differences in soft and hard water in the shower.
Exactly.
And how has the Water Resources Center funding helped you in your...
Well, certainly has helped me a lot. I mean, actually, one of the first grant of the Water Resource Center allowed me to get some preliminary data that and with that data, I was able to obtain a National Science Foundation grant.
Okay.
So that was a very big help.
So this grant has actually helped you get bigger grants?
Yeah, exactly.
Okay. And what, do you use the lab at URI?
Yep. Yeah, I use the
lab. Can you tell us a little bit about it? Without, you can leave out the really scientific terms, something that we'll understand.
Well, we have, I have right now in the lab, there might be three graduate students and 2 or 3 undergraduate students working for us. We have different equipment that help us to run this type of tests. Now we're using for this project that is the manometric techniques. We are trying a different approach because we realized that it was very difficult to separate the nanoparticles from the bacteria. So instead of spend a lot of time trying to separate them, we say, well, why we don't run the test together and we don't separate it? And basically what we are doing is trying to, we measure the disinfective properties of these nanoparticles based on how much are breeding the bacteria. Mm-hmm. So if the more toxic, the less, the higher disinfectant properties, the less they are breeding the bacteria. Okay. So we can measure that.
The smaller the number of the bacteria. So you're measuring bacteria to test the effectiveness of the nanoparticles.
Or nanoparticle. That's what we said, disinfection.
Okay. And have you been out in the field to test these, the filters, the ceramic filters that you've used with nanoparticles?
Not here in Rhode Island, but we have, with a collaboration with the University of Virginia, we have 2 field sites. One is in San Mateo, Ixtatan, Guatemala. Another one is the Limpopo region in South Africa. So we have there might be close to 100 or 150 filters distributed in these 2 communities.
Okay. Mm-hmm. And do you have to teach community members how to use the filter? Is it very self-explanatory?
It's very easy. It's very easy to use. But we usually partner with a grassroots organization or a local organization, so they usually teach or train the community to use it.
Is Potters for Peace an example of one of those?
Potters for Peace really, they do some training, but basically what they do is they set up this ceramic filter factories. That's their main goal. They are the producers of the technology.
That would be something similar to what you're doing, except not on the research end, but the production end.
Yeah. Okay. They basically, we work with them in order to develop or manufacture better filters.
Okay. Mm-hmm. And do you know of any shortfalls of nanoparticles as far as disinfection goes? What can't they do?
They certainly have a range of effectiveness. They don't kill everything. Yeah. Some of silver especially, they are not very effective with viruses. So that's why we are trying to investigate different ones. Certainly there's a big concern about what these nanoparticles are going to do once they are released in the environment. And we are very interested to study how these nanoparticles can be immobilized instead of adding a drop or amount of silver nanoparticles. That's what in the filters work very well, because we immobilize the silver nanoparticles in these filters and they are not coming out, or at least too much that we know. Yeah. But we are looking for ways to even prevent as much as we can the release of the nanoparticle from the filters to the water.
Is there some sort of safe disposal of these nanoparticles?
It's very difficult to separate because, as you can imagine, the size makes it almost impossible to retain them from the water.
Could you replace the filter entirely?
Yeah, you
can. Would that not be cost efficient?
Yeah. I mean, in what terms you are trying to?
Well, if you no longer
have the nanoparticles in the filter?
If the nanoparticles are always within the filter because they're so tiny, how would you dispose of the entire ceramic filter safely so that the nanoparticles are not released into the main water stream?
I think that, if they are immobilized, maybe you could dispose it in a landfill and they are still not going to be moving around.
As long as they're not within the water stream itself.
I think that the main concern is, especially if you are using something for drinking water purposes, is that consumption of this nanoparticle.
Okay.
You don't want people to be
So out
drinking
of harm's way.
nanoparticles. Yeah.
Okay.
Yeah, and then obviously the disposal, the better than maybe you immobilize these particles, the least of them, the smaller amount of them that are going to be coming out when you dispose the product. Or maybe you can recycle this system and incorporate the ceramic into a different product or create two more ceramic filters.
Okay, and has this project funded work done by graduate students? You said that you have some graduate students in the lab helping you out.
Yeah, I actually had fun 3 graduate students and maybe a couple of undergraduate students.
Has it been one a year?
Yeah,
Okay.
1 a year.
That's nice. I don't have very many more questions for you, so if there's anything you'd like to tell me about the projects that you've been working on for the past 3 years, feel free.
Well, I think that that's my main interest is really in nanoparticles, and see 2 things basically: the application of these nanoparticles for water purposes, and in that sense, I'm very interested to see how different water chemistries affect the performance of these nanoparticles. Also, nanoparticles, you can make them in very different ways. We didn't really talk about how to make them, but that you can, even though you can create silver nanoparticles, they can be slightly different from one another by modifying the surface. You can add different compounds to the surface of these nanoparticles, and that surface can have different, can make this nanoparticle to be more attracted to bacteria or less attracted to bacteria, or more attracted to bacteria and not attracted to human cells.
Okay.
So also we are investigating that, how we can change the surface of these nanoparticles so they can be maybe more benign for human and highly active for the disinfection of antibacterial.
Is this current research that's going on right now, or something you have planned for the future?
It's a near future type of study. Yeah.
So the questions have been raised, and you'd like to figure it out.
Yeah.
Okay. Well, I believe that's all that we have for today, and thank you very much for meeting with me.
Thank you for inviting me.